Hello, lesson 8.1, talk the talk. All right. 466. Now, histograms are a little bit different than the bar graphs that you're used to. One thing to know about histograms is the data here is continuous, meaning it's growing steadily. It's not like just a couple of things you're putting side by side to compare to each other. It is a kind of way of numbers growing steadily as they move across. The other thing to know about histogram is that this number, this 1, is the bottom of that box, or we call it a bin, that's to the right of it. Everything here is between 0 and just less than 1. Okay, so 1 is not included in the numbers right here. 1 is included in the bottom end of this bin. The other thing to know, the top, you've got to look across. That tells you how many times something within this range happened in the data set. Okay, so just a little reminder on histograms. Analyze each data representation to answer your question, justify your reasoning. And again, a key word here is bin. These bars are called bins. Another key thing to know is often this data over here is called the frequency. I mean, if I asked a whole bunch of people a question, or I kept track, this is inches of rain in Collinsburg. This is how many different months it was 3 inches. This is how many different months it was between 1 and 2 inches. I said that wrong, 3 inches. This is how many different months it was between 0 and 1 inch. This is how many it was between 1 and 2. Okay, describe the information presented. When they say the word describe, they want us to think about what does a graph look like? And some of the words we've been using to describe is symmetric and skewed. So looking at the rain in Collinsburg, is this symmetric or skewed?
Symmetric.
It's looking pretty symmetric. Why is it symmetric?
Because the highest point is in the middle.
Thank you. Write that down. How many months are represented on the histogram? Describe how you determine the answer. Now, the number of months on the histogram, you got to do a little detective work. You need to look at the top of each bin and figure out how many months represented by that segment. For example, this segment right here represents 3 months worth of rain data. This bin right here represents 5 months worth of rain data. Where did I get that 5?
Months.
From the side. So this bin right here, which represents between 2 and 3 inches, how many months did that occur?
8.
8. Go ahead, fill in the number on top of the line for the last 2 months. So what number am I going to put here, and what number am I going to put there?
2, 6, 3.
Wait, 2,
6.
6, and 3 was just frosting on the cake, right? Okay, so now the question is, how many total months? What do we have to do to those numbers to figure out total months?
It's 24.
How'd Jerry get that? 24 months. That makes sense. That's a nice even 2 years. And where did he get those numbers?
I bunched them up into eights.
Oh, he bunched.
The 6 and the 2, the 11 and 3,
Awesome. He added them, and he also told us a strategy. He could see, oh, there's 8 there, there's 8 there, and there's 8 there. So that's 3 times 8, that's 24. So again, 24 months, then you can get from adding total for all bins. Identify the intervals represented by each bin. Okay. So right here, this is between 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Again, this number usually you wouldn't say as being in this bin. It's the boundary. Everything here is less than 1. Anything that's over 1, we would count it in this next column. I wasn't sure, they didn't tell us these are in half inches or quarter inches. I wasn't sure what kind of fraction to use at the end. But we have 1, 2, 3, 4, 5 categories of data, and I made them into 5 little segments. How many months had 4 or more inches?
3.
Let's take a look. 4 or more. 4 or more. That table likes that 3 back there, huh? You've got a magic 3. Okay. What should that be instead of 3? 4 or more is this bin. How many months is that? I see a 2 on mine. Can you not see it? So question D, how many months had 4 or more? The only column that represents 4 or more is right here. And if I look across and I figure out months, that's 2. Describe the data distribution. Oh, I think I already did that. So what did they want us to do in A? Probably talk more about the scenario. So I'm going to, in E, say see above. But I might need to backtrack to A a little bit. Instead of saying symmetric right here, I think they wanted to look at the situation. What do you think Collinsburg is? Look,
town, the city.
Town. Amount of rain, inches of rain in the town of Collinsburg. We could spend a little more time on that, but I want to keep moving forward. We already had to backtrack. So when they just said describe, I think they wanted us to consider the situation a little more. All right, that's histogram. On your quiz tomorrow, there'll be a little bit on this way of looking at data. One key factor here that I'm not sure if we talked about on Friday was how if you want to know the total number in a histogram, you've got to look at how many in this plus how many in that plus how many in this. All right? Another key factor is in the question that asked 4 or more. You don't count these. All of these are less than 4. 4 starts here and goes to 5 right there.
You're at 5% of battery remaining.
This I'm having connection issues there.
You
Dismiss.
7.23 seconds.
Okay. It doesn't say charging. My little green light's on. Plug it in. Now we're good. Thank you. There we go. Okay. 2A. Now we have a dot plot. All right. Describe the information represented. What do these X represent? Look at the title. Participant who won gold medals in Special Olympics. What do the number lines represent? Memo. What does it say right here?
Number of gold medals won.
Okay. So, what do these two X's represent?
How many people got no gold medals?
Okay. So, information represented in the dot plot, number of people, and the number okay. Right now, I want you to do B, C, and D, because I think we've had more practice on those. I'm going to walk around and see how it's going there. B, C, and D, talking at your table. I think we can do this in 1 minute. Ready, go.
B, C, D.
B, C, D, please.
B, C, D.
Okay.
What?
Okay, keep going. There's B, now C and D.
Right? Myra got none. So we're like, they like,
It's like, it's actually counted here, because it's in front of you. So you got the one, the 10, and the one 14.
Good. How about D? Yeah.
It's lean, right? So it's
That's good. I'm hearing good stuff for the dot plot.
that's right. You heard from us.
Oh, you know what I found in here? Last week's homework. I don't see that in the bin. Oh, I found my copy. Last week's homework packet. Where is that?
Mr. Getty, is it the number of X's that represent?
Yes.
Those are okay, that's fine.
The number right here represents medals. The number X's is how many people won that medal. Good question.
Come on, homework packet back. I did that wrong.
I'll just steal this real quick. By Brian.
Brian, how many participants? Okay. Chris V, how many won 10 or more? Okay. Describe the data distribution. Symmetric or is it skewed? Good job. Skew right. The data is pretty symmetric over here on the left. but it has a couple way over here on the right. This is the skew, the things that are out of ordinary. Okay, and I saw most people writing those two things down. Okay, there will be a histogram tomorrow. There will be dot plot tomorrow. In fact, where's my Ruby? Let's have you copy what we need for tomorrow. So this, I need 27 Rigetti and 17 Morel. Back to back. Do you mind copying that for me? Do you know my code? 7-8. Okay. Box and whisker. Thank you. Oscar. Describe the information represented. Shh. Quiet, please. Here we are, number 3. Last kind of thing that we learned with our intro to statistics, box and whisker. What is this information about?
Volunteer hours at the local animal shelter.
And what does it say right here?
Hours for a week.
Okay, and so what are these,
Hours.
well, this is the hours, so what's
Volunteers.
volunteers? So the people who work a certain number of hours and how many hours per week. So how many people and how many hours they work. Excuse me. Memo! Are you with us in writing this down? I want to be able to give you credit, all right? Okay, how many people are represented in the box and whisker plot?
Wait, what? What was the question?
B.
Okay.
How many people are represented? Can we see? How many people? Where does it say how many people? Nowhere. This is hours. And the box and whisker divides it up into chunks of percentage. So of the people, there's 25% in each chunk. They're quartiles. But we don't, whenever it's a percent, we don't really know how many people, the exact number. So can't tell from looking at this. But we can answer C. What percent of people volunteered 14 or more hours? Where is that at? 14 or more hours. Okay, so 14 or more are right here. This is between Q3 and the max. What percent is between those two spots? 25%. 25 is up, 75% is less. Okay, but the question was 14 or more. So this is 25%, and I could tell you could see that. But looking at the or more piece means you wanted this side, and that's 25%. Questions? Okay, this is what tomorrow's quiz is going to look like. All right?
Is it a solo quiz?
Right now, I will say yes, it is a solo quiz. It looks like there's more on the other side. I don't know if we want to do that, because I do know we are supposed to start 8.2 today. That's all right. Let's do a couple of the questions on the other side. Okay, D. What percent of people volunteered less than 11 hours? Go find it. Less than 11 hours.
11.
Less than 11 hours.
37.5%.
Wait, hold on. Okay, look at this. 11 is probably going to be right about here. 11. That looks like it's lining up with the median.
Yeah.
Okay, so what percent is less than the median? 50. How many hours did the middle 50%? How many hours did the middle 50%? Let's see. Where do you find the middle 50%?
The Q1 and
Q1,
Q3.
Q3.
Here we go, right here. Here's Q1, median Q3. There's the middle 50%. How many hours? It looks like
Say Q1 would be 9.
that looks like about 9. So it looks like between 9 and 14 hours.
14.1.
The middle 50% go between 9 and 14%. Or hours. Oops. All right. Flip the page. You will need a calculator for what we're doing next.
Hey, Chris, can you give me one?
Okay, get 6.
How much is that?
What numbers you got? I'll take 6 for you. I'll give you 5. I'll give this one. There you go.
My bad.
And they're
Nice. Thank you. All right. Top of page 470. Starting on into 8.2. Jerry, would you read for us? 470.
Previously, you analyzed the data set by creating a graphical representation of the data. However, you can also analyze the data set by describing numerical characteristics or statistics of the data. A statistic is that best describes the center of the data is called a measure of central tendency. A measure of central tendency is the numerical values used to describe the overall clustering of data in the set. Two measures of central tendency are typically used to describe a set of data, are the mean and the median.
Okay, we talked a little bit about mean last week. Median we've been talking about a lot. What is the median? The middle. 50% are higher and 50% are lower. The middle of any set of data means of all the things I collected, half are below and half are above. Okay, so it's kind of a middle in terms of who you collect that info from. Mean, we said that number represents a different word you're more used to. What's the word, another word you might use for mean? Average. Make a note of that. The arithmetic mean or mean represents the sum of all the data values divided by the number of values. A common notation for the mean is x with a line on the top, which is read x bar. The E-like symbol actually is the Greek letter sigma, and mathematically it means the summation or sum. If you look down underneath that girl, they're showing you a new symbol that you're going to see here and there. And this means sum. It means add up all your numbers, put that on top, divide it by how many numbers you have. So if we were looking for the mean in a data set of 5, 10, 9, 7, 5, you add up the numbers, and because there are 5 different numbers, divide by 5. This is not different. What's different is the vocabulary of calling it the mean and some of the symbols involved. The mean is 7.2. Why don't I write the sigma when writing the data values in the formula? Because you're putting the pluses instead, I guess. Okay, back to sugar cereal.
Hey, don't talk this late, man.
Oh, public we need puffs.
Oh, it's Frosty Flakes. It's gotta be Frosted Flakes.
Okay. Is this the same numbers? This looks like the same numbers we had before. Memo. Put your screen down, please. Thank you. Represent the sugar amount of different cereals using the formula for the mean, then determine the mean of the data set. Here's what we need to do. X with the bar on top equals. This is going to be a big, huge, long problem. You need to write tiny.
Open your eyes.
Be nice. Big, long bar. And you need to go like this. 13 plus 4 plus, etc. Continue. Write them all down, please.
On both sides?
Yes. Both columns. Could you continue right here? Yeah, you may have to write small. You may have to continue down.
I think.
Fit 'em. Yes. Please. Notice on the bottom I put a 20. How did I get that 20? There's 20 if you count up the numbers. Now, go ahead and find the answer, please. You don't have to.
So you gotta go 13 plus 15
Yes.
21 plus how many?
Shh. I'm trying to like set numbers here.
10, 7, 8, 6, 7, 5, 10, 5, 4, 3, 4, 4.
Oh, there's 22 in there.
Yeah, we know.
No, there's a golden nugget.
Hey, guys, yeah, come. Okay, move on from the polarity of it. And, here we go.
7.89.
Lagging it. I did it first.
What do you mean?
You got number 2.
You ever?
Oh, Brian, guess what?
Oh, lucky one. So lucky. Hey, you're.
Okay, let's see. Clear.
On average, 157 divided by 8. Now you divide it by 1. So you get 7 point. What do you get, bro? Maybe we are. It's not yeah. No,
I'm getting 7.85. My mean. You gotta add up all those numbers, divide by 20. It was fate. What was it based on? I forget what we lined up by. Oh, we added up letters of their name. Oh, the Christophers ended up together. All right, now. I'm sure you're thinking, I know what an average is, but that was a pain in the neck. There has to be an easier way. Guess what? There is.
Oh, we didn't
But
say
we will learn the easier way tomorrow. So right now I need books away, calculator. Oh wait,
yeah, sorry.
I keep forgetting what time this class ends up. We have more time.
We have 10 minutes.
Flip the page. Is that cruel? Hey, here's the deal. Here's the deal. You can just watch me. All right? How about that? But sit. No. Watch me doesn't mean slapping stuff around. Sit. There we go. Shake. You're going to be able to use your calculatora. Okay? Too much motion. Calculatora. There's a button on your calculator called Stat. Find that button. There it is. Not stat plot, stat. It's right underneath delete and above program. Stat. That's going to help us deal with huge batches of numbers. Press stat. Where it says edit, we're going to press enter. And we're going to be able to put in our numbers into a list. We've worked with lists before, yes? Okay, so I've got something in my list. I'm going to go up to list 1 and clear it. Enter. And then I can go in and put all of those numbers that I just did, 11 plus 7 plus 10 plus, we can add it into a list. And we're going to look at the kinds of things that the calculator can do this, relationships and patterns that it can show. All right, we'll take that off tomorrow. Okay, go ahead, continue. Books away, calculators in the box. Ah!